name is Elnara Iskandarli. I'm a first year undergraduate student at 88 University, and today we're going to talk about modeling with exponential functions. So I'm going to start with the definition of exponential function. So exponential function could be written like this, where a is a constant. It could be any number except for 1, and the variable x is the exponent. Yeah, and it could represent either a rapid growth or a decay. However, today we're gonna expand more on exponential growth. Yes, exponential growth, doubling time. Let's imagine that we have one bacteria, just one single bacteria, and it doubles every hour. So this is just now one bacteria, then after 1 hour it's 2, then 4, then 8, and such. So how could we write this as a formula? It's simple. So the number of bacteria equals the initial multiplied by 2 to the power of time, because it doubles every time, every hour, or it could be second, minute. It depends on the situation. So here, if we write, for example, 3, and our initial number of bacteria is 1, multiplied by 2 to the power of 3. We want to know how many bacteria is going to be after 3 hours. That's 8. That's it. Now we're going to solve the questions from the book called Steward, Pre-Calculus. So first question is about the bacteria itself. So bacterial culture, a certain culture of the bacteria I can pronounce. A initially has 10 bacteria and is observed to double every 1.5 hours. So A, we need to find an exponential model, write it as this, for the number of bacteria in the culture after T hours. So A initially has 10 bacteria, so our initial number should be 2.5 10? Yes, 1.5 hours. Write this. That's 10 multiplied by 2 to the power of 1.5. This is our equation. Estimate the number of bacteria after 35 hours. So to estimate the number of bacteria after 35 hours, we should just substitute 35 to the formula. So it's 10 multiplied by 2 to the power of 75. Then approximately is some big number. Like it's around, 105 million. You can solve it using a calculator. Approximately this number. Okay. And C. So C says, after how many hours will the bacteria count reach 10,000? So to know after how many hours it's going to be 10,000, we just substitute this by 10,000 and equal to this equation. I know, we already know it's 10, 2 to the power of t, and it's approximately 15 hours. You can also use calculator for this equation. Yeah, and it's that's it. Then, second equation is also about bacteria, so I'm not going to solve it yet. Third equation. Third question is about square population. So beside the bacteria, the number of bacteria, we can solve it for the population, whether it's squirrel or bird. How is it described in the next example? So it says, a grey squirrel population was introduced in the certain country of Great Britain 30 years ago. Biologists observed that the population doubled every 6 years, and now the population is 100,000. Okay, so we need to find what was the initial size of the squirrel population. Now we need to find the initial size using the model. So we write 100,000 is equal to initial that we need to find multiplied by 2 to the power 30 divided by 6. By the way, this, when it is like every hour, is just t, right? Every hour, every second, every minute, depending on how it's measured. However, what if they ask us it is doubled every 3 hours, every 6 hours? How it is written here? We just write same n2 to the power of t divided by 8. Like whether it could be anything, like as I said, like double every 3 hours, every 2 hours. So if the bacteria, let's say, if before it was 2 to the power of 2, so and it could be n was equal to 4. If it is double every 2 hours, we will reach the same number only after 4 hours instead of 2, because it doubles every 2 hours, not 1. And that's it. So heading back to the question. It's gonna be approximately 3,125. So it's good. Then B. Estimate the squirrel population 10 years from now. So we write it like, you can either write 100,000 and multiply by 2 to the power 10, 6, and it equals some big number. You can calculate it. Or you can use the initial size of the population and write it like this. It's gonna be the same thing, right? And the last one, C. Sketch a graph of the squirrel population. So based on our findings, it should approximately look like this. Here, when 0 is 3,125. When it's like far here, it's like 30 years. And it's meaning 40 years is somewhere also there. 300 something. It's somewhere here. Something like this, should stand rapidly. So that's it. This is the modeling with exponential functions. I hope it was beneficial, and thank you.